Yep. So Beth now has walked you through the data section of the platform as well as the group stuff, and I'm just going to go through the modeling and the workflows steps, showing you how to upload a model onto DAFNI and then how to use that model in a workflow. So we're going to here to start with. This is our list of models on the platform. Again, I can see more stuff here because I'm logged in as an administrator, but as Bethan just said, you can share models with other users in the same way that we can share data sets with amongst users as well. So these are all the models that we have currently on the platform. A lot of these came on as a result of pilot projects that we did earlier in the sort of platform development, which Brian talked a little bit about. But more recently, a lot of these models are actually being actively uploaded by our users and worked on by them, which is really cool to see because it means that we've built a platform where people can actually come and upload their own models without too much intervention from us, or in lots of cases without any intervention from us. So that's really nice to see. But for the purposes of this demo, I chose to use the COVID model, which came out of Imperial College London. So they've been working on this COVID-19 model, and I thought that makes quite a good demonstration of the kind of thing that you have to do to get your model onto DAFNI. So you head over to Add Model, and then we've got a lot of documentation available in terms of how to actually go about getting your model DAFNI ready. And we've also got plenty of YouTube videos as well online that you can find that walk through the process in more detail. So hopefully there's plenty of information out there to get started. But if you ever have problems, we've got a Slack channel where we're all pretty active. Every member of the DAFNI team is there to sort of help you out, and other users of the platform as well, which is really cool. To have a click into some of this documentation, you can see the first thing that you need to do is write your model definition file. So this is a YAML file which has all of the metadata about your model in it. So it has a title, a description, a list of the parameters that it takes, a list of the input files that it takes, so input data sets, which you can get from the data catalog that Bethan just showed you. These input parameters will be injected as environment variables into your model once it runs, and so users can change those at runtime. They can quite easily alter those through the front end, which I'll show you in a second. And the second thing that you need once you've got your YAML file is a Dockerized version of your model. So for those of you that are unfamiliar with Docker, it's essentially a way of packaging up a load of code and then shipping it off. And then when it's unpacked on the other side, we can sort of guarantee that it runs the exact same way on your machine that it runs on DAFNI, because Docker ensures that the initial operating system is the same, all of the same packages are installed, it's running the same version of Python or R that you're using to actually run your model. But it also lets us be agnostic in the way that, like whatever programming language your model is in, we can accept that as long as it's Dockerizable, essentially. So you've got this containerized version of your model that's then uploaded onto DAFNI. And just to give you a little bit of an indication of what all this stuff actually looks like once you've done it, this is the equivalent stuff for the COVID-19 model. So you can see I've got a display name, lengthy description, which I just stole from the GitHub page, and then a load of environment variables that the users can change, and then a list of the output files that come out of that to give any user that's interested in my model an idea of what's actually going to come out at the end of it. A doc file looks something like this. So the first line is always the base image that you want to pull from, and this is usually just an operating system. So here I'm using Debian, and then all of these packages get installed. I clone in the repository from GitHub, install some more packages and run some install scripts, and then this is all fairly technical and I wouldn't worry too much about this, but the very final thing you do is to actually run the model. And so once I've got that Docker file, I can build the image on my own machine, and then I can upload that onto DAFNI. So I've done all these steps, and obviously that's like a very whistle-stop tour, but I select my definition file and I've essentially just zipped this up, so it's a bit of a smaller upload, and then press upload. So we won't wait for that to actually upload because it will take a while just because it's a sizable file, but I did one earlier on. So this you'll see is just an exact copy of the stuff that was in that metadata file, but in a nice front-end format. So you can imagine users browse to this page to get a bit more information about the model. They can see tooltips on what each of the parameters offers them, and they can get an idea of what comes out. But obviously now we need to actually run this model and do something with it. So if we go over to workflows, this is kind of like the meat of the modeling service. This is where we actually come to be able to do stuff with our models. And so if we head to create a new workflow, and we'll just fill in some dummy metadata for now. And so this is our workflow system, and Rose and Christian will probably talk through this as well in a bit more detail. But essentially, in our workflow builder, we have 4 different steps that you can choose from. The first is an iterator step, which allows you to iterate over the same model step multiple times and change a given parameter in that model between a maximum minimum value. So you'd probably use this if you want to do some kind of sensitivity analysis. In our use case, we could perhaps alter the R number between 1 and 2 and see how that affects things like case rates and hospital load and stuff like that. I won't put in an iterator step at this point. You can see how that could be really useful for that kind of study. The next bit is where we actually inject our model. So we'll call this step COVID, and then we can just go back into the catalog. You can still search over the catalog, select our COVID model, and then this parameters section down here gets populated with all of the things that we can choose. So we can change the country, we can change the R number, we can change how many people are complying and that kind of thing. There were more parameters available for the model, but just for the purposes of the demo, I didn't suck them all into that definition file. And then down here, if we had input data sets to our model, this would get populated as well, and we'd be able to choose that. So you can imagine this model could take in something like census information to get an idea of the population distribution. If you then had a new census come along, you could then swap out those files down here in this section. So you could run it with a different input data set. So we can create that step. And then if we wanted to see how COVID might affect, I don't know, house prices or electricity costs and stuff like that, we could then add another model step and take the outputs of the COVID model and use those in another model. And so you could build up a chain of models. And again, Rose will show you how that works in a bit more detail. But for now, we'll just stick to the single step. We then have 2 methods of getting data out of your model. So one is this publish step, which you could, I don't know why that hasn't changed. There we go. So one is this publish step, and this will essentially take the outputs of your model and publish them into the data catalog. So if I switch this off, you'll see the exact same metadata form that Bethan was using earlier. And so you can assign all that metadata to the data that comes out of your model and then publish that into the catalog. At the point of publish, it will be private just to you. You can then choose to share that with other users from there. So that's a way of getting data out of your model. And the other step that we have, the final step type, is visualization. And so this lets you spin up a visualization to do some kind of post-processing on your data that comes out of your model. So this will also publish a data set to the catalog, but it will also spin up this visualization for you to be able to do that post-processing. At the moment, we only have one visualization type, which is this Jupyter Notebook. And for those of you not familiar with Jupyter, I'll show you in a second. But Jupyter essentially involves writing some code to produce visualizations or to do that post-processing of your data set. And obviously we're aware that not all of our users will be technical, so they won't necessarily know how to write that code. So we're currently working on implementing another kind of visualization, which will allow people to create graphs and plots much more easily just by dragging and dropping stuff on a user interface, essentially. And so we're hoping to have that in sometime in April, and that's something we're actively working on at the minute. But if I select Jupyter Notebook for now, call this step viz, and then I could fill in all this metadata because the data set still goes into the catalog, so we still need to assign some metadata to it. We could then create that step at the bottom and create that workflow. And then from there, we'd go back into here and we could execute it from here, and that would set off a run of that workflow. But the COVID model does take about half an hour to run, so I did just run it earlier so we don't have to wait. So this is a completed workflow. As the workflow goes along, you would see this little tick change from 3 different symbols, which shows pending, currently running, or completed. This tick shows that both of our steps have completed here, so we've got a visualization step. Press this visualize button, and that will take us into our Jupyter Notebook. And again, the COVID-19 people at Imperial kindly have provided a script to visualize the data that comes out of their model. So these are all of the output data sets that have come out. So we can see this is fairly horrible to browse in the Jupyter Notebook itself, but they're just CSV files that we could download and play with from there. But what this is an R script, so it's just a load of code that essentially extracts stuff from these files and then plots it. So if we run that, we can then get some nice graphs of the data that's come out of our workflow. And again, it's worth pointing out that obviously this is only really useful for technical users where they're able to write the code, and we are actively working on something to help non-technical users come up with visualizations as well. And that was kind of it from me. So